So today we have a hard problem. Given these numbers left, right, n, we want to find how many zigzag sequence of numbers we can make in a range L up to R, and we're not allowed to make them equal or descending in 3. So the solution is the dynamic programming. First the naive solution is that we doing top-down DP, and okay, in that DP we use some depth first search from position, and then we have previous number, and then we have a flag that we have to decrease, decrement, or increment. And inside we iterating from the left up to the right, and depending on this descending we adjusting left or right, and do call DFS of I plus 1, this current value, a k, and then the decrement would be like not decrement, like this. And this solution gives time limit exceeded because it has two n squared arguments, each the range of n, and inside itself it has n, so total O n cube. I myself didn't solve this problem in O n square. However, you can try to derive how your functions can be simplified. So if we have imagine we have this call for the DP, and it equals the sum from left, the k equals from lower up to the p minus 1. This would be f. This would be I plus 1, k 2. And to make a jump from this n iteration to more simple, more fast mathematical trick, you have to do this kind of jump from p to p minus 1. So look at this, we stay the same I. This would be p minus 1, this would be 1. So we're trying to look how this jump of p, we only moving this p, changes this sum, and it turns out it is basically the same, just p minus 2, and the inner formula is absolutely the same. And we have these two equations. We can do operation minus on them, so subtract the first one from the second one, and we have ip1 minus f ip minus 1 1 equals, and this sum subtracts just by the last argument. So the entire prefix of this sum is the same, and only this last step is difference. So it is the last step, f I plus 1, and this is a p minus 1, and this is 2. And move this to the right, we have the formula for simplification equals f I p minus 1 1 plus f I plus 1 p minus 1 2. So this is, instead of doing this big sum, we simplified it to just 2 calls, recursive calls. And we can do similar for the argument of 2. This is increasing, this is decreasing, or vice versa. It doesn't matter. And this would be f I p plus 1 1 plus maybe it's 2 plus f I plus 1 p plus 1 1. So this is what we place instead of this for loop. It thus gives us O of n squared solution, but it's still time limit exceeded in this exact lead code test cases, like they ask us to do this bottom up, and for the bottom up I completely gave up and just take solution from the other guy. So we have this conversion from the range to just maximum from 0, and another simplification is to use a symmetry to multiply by 2 instead of calling it up and down. And this is bottom up. So if we go, we either go up or down, and if we go up, we iterate forward. If we go down, we can iterate backwards. And this is a prefix sum. Okay, I can't explain it to you because it's not my solution. Okay, that's it for today.